Let's start working on question C now. Suppose that the firm cannot observe effort and the scheme is A plus B times Q, where A is a fixed salary and a bonus based on production. So we have to find out the profit maximizing level of the base salary A and the bonus B. Okay, now before solving this, we have to understand here the intuition, and the key point in this question is that the firm does not observe effort. Now, what does that mean? We're going to compare this thing with the previous two videos. In the previous video, when we started, the firm was observing effort, if you recall that, right? The firm, or was it? It said somewhere over here that the firm, here, suppose the firm observes the worker's effort. What does that mean? Well, we saw that to find out the effort that the worker is going to put, we maximized the profit function with respect to the effort level, because the company decided how much the worker to work. The company, the supervisor, was literally watching the worker, and he made sure that he is putting in a certain amount of effort to make him the most profits, because the company was observing that. Now the story is different. Now the company cannot observe it, meaning that the worker decides independently how much to work, what is his effort level, and his effort level is going to depend on his own utility, on his own happiness, meaning that now we're going to maximize the utility function with respect to effort, whereas before we maximized the profit function with respect to effort. Hope you see the difference, because that matters. That's all that matters here. Now, this is the utility function. We know that the wage is different, so let's write this in a different way and maximize it and see how that changes the variables. So we have actually let me go below because we'll need more space here, over here. The utility is equal to the wage, which is A plus B times Q, and we know that Q is a function of the effort level. That's theta times the effort level, so let's write it like that. We have A plus B times the quantity, which is theta times the effort level, minus the cost of effort, and the cost of effort is still the same, minus this thing, 1 over 2 theta e to the power of 2. 1 over 2 theta e to the power of 2. What do we notice? We notice a quadratic relationship between the effort and the utility, because again, e is to the power of 2 with a negative coefficient. So again, we're looking for the peak of that parabola, meaning we're going to differentiate the utility function with respect to the effort level and make it equal to 0. How is that going to look like? Well, let's see. A derivative with respect to effort is just 0 because it's a constant. B times theta times e derivative with respect to effort is just B times theta, minus 1 over 2 theta times e to the power of 2 derivative with respect to effort is 1 over 2 times theta, which is the constant. The derivative of e squared is 2e. This must equal to 0. Now let's cancel out some stuff here. 2 and 2 go away, so we're left with b theta minus theta times e equal to 0, meaning that b times theta equals to theta times e, meaning that e is going to be equal to the optimal effort level is b theta divided by theta. This is the effort that the worker now chooses to maximize his utility. So let's just write here the highlight. Worker maximizes utility with respect to effort level. Now with that said, what do we still need? We need to pay him a salary, right? That's what we're looking for. We're looking for the profit maximizing level of the fixed salary and the bonus. Now, to pay him a salary, we must make the worker work for our company, meaning we must attract the worker. So we must make him attracted to us by at least covering him the alternative utility, the alternative V. So let's do that. We'll do that over here. That's going to be our second step. So U must be equal to V at least, right? To attract the worker. Meaning here, company must attract worker. That's the highlight. Must attract the worker. Now with that said, what is the utility? Well, we saw what is the utility. The utility is, let's just write it here again. The utility is going to be equal to, where was it? From here. Let me actually zoom out to see more of the things we're doing, because otherwise we have to scroll up and down a lot. This is the utility, a plus b times theta times e minus all that. And we're going to replace e into our function because we have it in terms of b theta over theta. Anyway, first things first, let's just write the utility. So the utility is going to be equal to a plus b times theta times e minus 1 over 2 times theta times e to the power of 2 equals to v. That is the constraint that we are working with. Now, instead of the effort level, we're going to substitute the optimal effort, right? We want to see what that's going to be. So we will have the following. We will have a plus b times theta times, what is the effort level that we found? That's b times theta over theta, b times theta over theta, minus, we go to the cost of effort, minus 1 over 2 multiplied with theta multiplied with the effort to the power of 2. So we're going to have again, let me just use green as well to keep the color the same for the effort. So that's b theta over theta to the power of 2 equals to the alternative utility v. So that's going to be equal to v. Now it's a matter of doing the math over here. So let's do the math. We will have a plus b times theta multiplied with b times theta. Well, that's just b squared times theta squared divided by theta minus, we have change colors, minus 1 over 2 times theta times, and we open these brackets by raising everything to the power of 2. So we have b squared times theta squared divided by theta squared equals to the alternative utility of v. So that's equal to v. Now we can cancel out some stuff over here to make the math look better. Theta and theta goes away. So we have a plus b squared theta squared divided by theta minus, so we have minus 1 over 2 times b squared theta squared divided by theta equals to the alternative utility of v. So that's going to be equal to v. Okay, what do we have here? We're subtracting a term, two terms, which are the same, b squared theta over theta, b squared theta squared divided by theta, but then the coefficients are different. The coefficient here is positive 1, and over here it's minus 1 over 2. So 1 minus 1 over 2 is just 1 over 2, meaning we have left a plus 1 over 2 multiplied with the remaining term, which is b squared times theta squared divided by theta, and that's equal to the alternative utility of v. Now we want to find out the salary, the fixed salary to attract the worker, meaning that we're looking for a. So as a final step, we'll just write the a solution, right? The optimal solution for a is going to be v, and we take this term on the other side, v minus 1 over 2 b squared theta squared divided by theta. By paying this amount, we are attracting the worker to work for us. Hope this all makes sense. In the next video, we'll finish the question by finding out what is the optimal bonus to maximize profits.